Okay, hi. So today we learned the properties of logs, and I kind of told you we were just going to review, but then today we walked into class and Mr. Hill was all like, you guys have 5 minutes to finish your warm-ups because today is the hardest day of chapter 2. So now I feel bad, so I'm going to teach you the lesson really, really quick, okay? Okay, well, it's really not going to be that quick because it's kind of confusing, but okay. So we learned the properties of logs. So the first property is change of base. So, oh gosh, pencil. Okay, pen. Change of base. And so let's say your logarithm was log b, or log base b of u. So you would just take the basement stays in the basement. So that's why it's still down here. So it would be log u over log b. So whatever number is right here is going to go on the top, log whatever, and this is going to go on the bottom. And the whole reason to do this is because when you're dividing this in a calculator, you want to make sure that the log bases are the same. And on a calculator, the log bases are always 10. So remember how, like, if there's nothing here, it's going to be log base 10. So by changing the bases, we made it log base 10 of u divided by log base 10 of b is the same as log base b of u. So I don't know if that makes sense, but that's the first part of the notes. And then you can just, kind of like click pause and write this down and try to understand it. And then now you're going to click play. So then we're going to move on to property number 2. Property number 2 is the product property. And these, like, all 4 properties have pretty simple names. So what you have is you have log base b of u times v. So, like, remember when we had, like, it would say x to the 4th power times x to the 3rd power is x to the 7th power, and you would just add the exponents because the bases are the same. You're kind of doing the same thing here, but you're kind of working backwards. So you have log base b of u times v. So log base b of u and the log base b of v from this v over here, and then you add the 2. So instead of adding, because they give you, like, these 2 numbers are being multiplied, so then you add this one, and then you add this one. Does that make sense? Okay, well, you kind of have to make sense. You have to, like, yeah, it just has to make sense. So, yeah, just log base b of u times v is the same as log base b of u plus log base b of v. And then the third property is quotient property. So you have log base b of u over v equals log base b v minus log, sorry, this is wrong. Okay, so scratch all of that. So what you have is log base b u over v, which is equivalent to log base b to the u, so this should be a u, minus log base b of v. Dude, I've been filming the wrong part. Let's start over. Anyways, so okay, quotient property one more time. It should be log base b log base b of u over v. So then you would do log base b of u, because remember, whenever you do division, you want to subtract from the top, from the bottom. So you have log base u minus log base b. Because remember when we had, like, x to the 7th over x to the 4th, you would get x to the 3rd, because you would subtract the top from the bottom. That's a really ugly 3, but it's okay. So you're basically doing the same thing here. So you have log base b of u over v equals log base b of u minus log base b of v, because you're taking the top and then the bottom, and you're subtracting the 2. The top always gets subtracted from the bottom, no matter what. And this is the last property. The last property is power property, and so let's say wow, that is an ugly G. Hold on, let's fix that. Okay, So let's say you have log base b of u to the n power, and that is going to be equal to, this one's the one that's kind of confusing, and so that one's going to be equal to n log base b of u, because whatever the exponent is, so like over here it's the n, you can pull that out and bring it to the front. So does that make sense? So let's say you had like log base 749, so let's say you had log base 749 2. You can pull this 2 out and you would get 2 log 749. And so these two are equivalent to each other. So log base 749 squared is the same as 2 log base 749. Okay, so then let's do some practice problems. Okay, don't you, I'm like another Mr. Hill, but like a girl version. Okay, honestly, I would suck at being a teacher. Okay, so hold on, let me get another piece of paper out. Wow, I don't have any paper. Let's walk around and go get a piece of paper. Wow. It's kind of blurry, huh? Okay, paper. Here's my other binder. Okay. So, oh, 1 second. Shoot, I forgot I was texting someone. 1 second. Okay. Okay, so let me write the directions. Evaluate using change of base. Okay, so the first problem is going to be, I'm going to give you 6 because that's how many we got. Okay, so evaluate using change of base. And for the problems that come out in decimal form, just round them to the 3rd decimal. So the first problem is log base 3 of 81. The second problem is log base 3 of 7. The third problem is log base 32 of 2. The fourth problem is log base 1000 of 10. The fifth problem is log base half of 8. The sixth problem and final is log base 9 of 2 over 5. I'll do the first one because I know that in class it didn't really make sense what we were supposed to do. So what you would do is this equals, so remember this is where you do the base change. So you're doing log u, which is this, over log b, because this is the b, right? This is the base, and the base always goes in the basement, so make sure it's always on the bottom. So you would do log 81 over log 3. And then you would need your calculator. So